Well, as we delve further into polynomials in this unit, we're going to have to know what to do with integer exponents. How do we take care of exponents? Because there are certain laws and stipulations that we have to abide by, and we're going to be getting into that quite a bit when we go to working with polynomials. One of the first things that we want to talk about is the zero exponent. Here it is in a nutshell. And that is any number raised to the power of 0 is equal to 1. Anything raised to the 0 power is 1. Another thing we need to think about and keep in mind as we work with exponents is that we can't leave a negative exponent as an answer. We cannot have this. So if we can't have a negative exponent, what do we do? It's very simple. Don't think about it. Just do this. Anytime you have a negative exponent, if it's in the numerator, if that number raised to the negative exponent is in the numerator, switch it into the denominator and you make the exponent positive. If that number is in the denominator, switch it into the numerator and you make the exponent positive. That's it. Don't think about it. Don't have to understand why right now. We'll get into the whys later on. But for right now, just know that if you have a negative exponent, it doesn't make the number itself negative. Here's what we need to think about. Whenever you have a negative exponent, think fraction, which means you need a fraction bar. So if you have a negative exponent, start with a fraction bar. We'll talk about how that works in just a few seconds here. But notice that the exponent tells you how many of these things you're multiplying. So 5 to the third actually means 5 times 5 times 5. We get 125. 5 squared means 5 times 5. You get 25. 5 to, and notice this is how many 5s I write down. I write down 1 5 and I get 5. How many 5s am I going to write down here? No 5s, but what other factor do I have? And here's what I mean by this. Isn't 125 equal to 1 times 125? And 25 is 1 times 25, and 1 times 5 is 5, and I still have this factor of 1 to deal with. 5 to the 0 power is equal to 1. Now, here's what we mean by the negative exponents. This is 5 to the negative 1. This is already in fraction form. We just don't write the over 1, right? Well, whenever you see a negative exponent, think fraction. So give me a fraction bar. 5 to the negative 1 power is going to get switched into the denominator, and I get 5 to the first power, 1 over 5. 5 to the negative 2 power is 1 over 5 squared, which is 1 over 25. 5 to the negative 3, it doesn't make the number negative, it creates a fraction, 1 over 5 to the third, which is 1 over 125. So always think fractions. And here's what we mean by this. 4 squared, obviously you can plug that into your calculator, 4 squared and get 16. 3 to the negative 4. What this means, now 3 to the negative 4, that's over 1. Anything that has a negative exponent, if it's in the numerator, we're going to put it into the denominator. So as soon as I see a negative exponent, fraction bar. Now the 3 to the negative 4 gets slid into the denominator, get 3 to the positive 4. There's nothing else in the numerator except a 1. You always have a factor of 1. Why we go back to this? 5 to the 0 power. There's always a factor of 1. But anyway, back to our original problem here. 1 over 3 to the 4th, 1 over 81. In number 3, this 2, the exponent 2, covers only one thing, and it's whatever's immediately to the left of that exponent. So this 2 covers the parentheses, which means everything in the parentheses gets squared. We have 2 squared, we have 3 squared, 4 over 9 would be your final answer. What's 7,645 raised to the 0 power? 1. What would be 7645 x to the 0 power? 1. Doesn't matter what it is. Everything raised to the 0 power is equal to 1. In number 5, we don't have any negative exponents, so we're just going to evaluate. 2 to the 3rd power, 8. 3 to the 4th power, 81. Number 6, negative exponents. What are you thinking? Fraction. So start with a fraction bar. The 5 to the negative 2, it has a negative exponent, so we're going to put it upstairs. 5 to the positive 2. The 4 to the negative 1 goes downstairs. 4 to the positive 1, or just simply 4. 5 squared is 25 over 4. Final answer. Number 7, what do you see here? A negative exponent. What are you thinking? Fraction. Make a fraction bar. 6 to the 2nd power. That exponent is already positive. That doesn't move. We leave it 6 squared. But what do we move? 5 to the negative 3 goes into the numerator, and we get 5 to the positive 3. Just move it, and it makes the exponent positive. Now we put this over 1, but we don't use a 1 in the denominator, so I'm going to ignore that fraction bar. I'm going to take 6 squared is 36. Times 5 to the 3rd is 125. 36 times 125. 36 times 100 is 3,600 plus 900 is 4,500. Seven squared times 3 to the negative 4. This is over 1. There's already a fraction built in. Anything by itself would just be over 1. I need a fraction bar because I have a negative exponent. Anytime you have a negative exponent, fraction bar. 7 squared, where does it go? It stays in the numerator, 7 squared, because it has a positive exponent. Now the 3 to the negative 4, that gets moved. 3 to the positive 4. What's 7 squared? 49. 3 to the 4th, 81. Final answer. And number 9, 3 sevenths to the negative 2 power. What this is saying is that this negative 2 covers one thing, and that's the parentheses, which means everything in the parentheses gets raised to the negative 2 power. If it's in the denominator, put it in the numerator, make it positive. If it's in the numerator, put it in the denominator, make it positive. 49 over 9. Don't think about it. Just do what the rule says. The rule says if it's in the numerator, you slide it into the denominator and make the exponent positive, vice versa. Number 10 says we're covering everything the 2/5 is raised to the 3rd power. That means 2 to the 3rd, and it also means 5 to the 3rd. 2 to the 3rd is 8, 5 to the 3rd is 125. Final answer. What's number 11? You got it. 1. Anything raised to the 0 power is 1. The 1/2, both the 1 and the 2 are raised to the negative 4 power. So 1 to the negative 4, 2 to the negative 4. You could probably see what's going to happen here. The 2 to the negative 4 gets into the numerator, makes it 2 to the positive 4. The 1 to the negative 4 makes it 1 to the positive 4 in the denominator. We don't use a, remember, well, what is 1 to the 4th power? Yeah, it's only 1. 2 to the 4th power, 16. We don't use a 1 in the denominator. Final answer. Good luck on your assignment. We will see you in class. Remember, you can always go back and review this, pause it anytime you need to or whatever. So good luck on your assignment. We'll see you in class next time.